In this video, I'm going to go through some R basics that will allow you to get started quickly and get up to speed on the R commands we will be using. There are a lot of other R introductions available online that you could go search and get more details. I want to just give you the basics that will allow you to quickly get started. So here we have RStudio, and you can run R without RStudio, but it allows us to work with some visual tools that make it easier to work with some of the data that we're going to use. So I will go through some of the basic commands and language items that we will be using, and I will do that here in this simple code that I have set up here that isn't really designed to do anything other than to introduce some language components that we're going to use. First, let me outline some of the structure of RStudio and similarly R to help us know how to work in R. Here in this window pane, what we have is the R script. So here we can write and keep and save code that we're going to use to run our commands. We can do the same things down here in the console, but the console doesn't save and allow us to run multiple times the same script. So up here, if we write things and save them in the script, then we can run it at another time. If we run it here in the console, that doesn't get saved, and the commands get mixed up with the output that we're going to be looking at as well. Over here on the right, we have the environment that shows us things that are available to us in the R script, as well as some other windows here that can be useful, and we'll go to them at some point. Along with the code that we have here, we have this run button. This is going to be one of the important items that we're going to use. We type in the code here or down here and we hit run, or if we type it in the console, we can hit enter and it will run the code as well. To start, throughout the code, we usually leave in comments. The comments are not run through the R system, so we identify those comments with this number sign, and we can put any comments after that in the line. So if I put in a number sign or the pound sign or the hashtag, whatever you would like to call it, I can put in comments here that will allow me to keep track of what I'm doing within the code. So you'll see here I have comments as we go through that identify the topic that I'm working on, and similarly in code that I will use throughout the course and that you might use, I would keep comments about the steps that I'm doing, because for most of us, just reading the code isn't always intuitive. The comments help us to remember those things that we're doing. So let's get started with some of the basic commands in R. R is called an object-oriented language, which means we create objects and then work with those objects. So here I'm creating an object that I'm going to label A, and this is called the assignment operator, meaning it looks like an arrow, so the things that are on this side, so here this 1, goes into the object that I'm creating A. So I name something on the left-hand side. Using the assignment operator, I put something in the object that I'm creating, and here I'm just putting 1 into that object. So if I run this piece of code, so I can do that by highlighting it and then clicking run. There are other ways to do it as well, but we'll do this way. Notice what happened is down here in the console, it keeps a log of what I have done in the code and some of the output as well as warnings or errors. So here it tells me that I created an object, that the object contains the number 1. If I look over here, it says I have values in my environment that is A, and the contents of A is 1. So if I just type in A here and run that, or I could type in the console just A, it outputs what the contents of A are, and that says it has 1 item in A, and that 1 item is the number 1. So I could do the same thing. Let's say I'm going to create an object called B, it outputs a number that is 5. So I've created an object B. The only thing it contains is the number 5. So again, we have one item in that object B, and it is output the number 5 because I ran this code here that says, tell me what's in object B. Well, then I can start to work with those objects, and there are lots of ways that we can work with those objects. Here I'm just going to do something simple. Let's say I want to add A and B together. Well, A and B is now the object C. So I created an object C, assigned to it what comes after the assignment operator, and that is a function of A and B. So adding A to B is what will come out in C. Well, when we run C, you can see the object comes out with the number 6, or over here in our environment it says we have an object C that what it contains is the number 6. So we can do similar things with everything we're going to do is going to be using these types of objects, but of course they'll be more complicated. If this was all it was, we wouldn't need to use R. So let's introduce a couple of other objects. So we can do a list object, which means combining items together. So here I'm going to create a new item. I'm going to name it list. By the way, this is lowercase lst in our case matters. So we might have capital LST that is different from this lowercase lst. So I'm creating an object LST. I'm going to assign to it a list. So C with parentheses creates a list. So I'm creating a list that is 1, the number 1, the word 2. So I need to put text into quotation marks, and then the number 3. So I run this. Notice over here I have this object list that is a character object, and it has 3 items. Well, if I want to pull out one of those items from the list, I can use these square brackets, and square brackets, what they do is look at some subset of the object. So here it's a list object. It has 1, 2, 3 items, so it's going to pull out the second item of this list. So I can run that. Look what happens in the output. It says I have one object that was output. That's because I used this command, and it was the word 2, which was the second item from this list. We can use these square brackets to pull out lots of different items. We'll do some of that in a minute, and we'll use this throughout the course in different ways. So let's move from a list to a data frame. The data frame is going to be the object that we use most frequently when we have a large amount of data that's lined up in sort of like an Excel spreadsheet. Let's create a data frame here, and how we do this is I'm going to create an object again, assign to that object this command over here. And this command says I'm creating a data frame, so data.frame creates a data frame. There are other ways to read something in as a data frame when it was something else, which we may use in the future. But here I'm creating a data frame, and I'm going to name each column in the data frame. Here I'm going to name column 1, column 1, column 2, column 2, column 3, column 3, or I could change that. Let's say I don't like to type in long names, so now I'm naming them column 1, call 1, call 2, call 3. And in these, I'm going to create different rows within that column. So each row is a list, but it's going to set it up as a data frame. So I need to have the same number of items in each list because these will be the rows in a column. In column 1 here, I'm creating text. Notice these are in quotation marks. So I'm going to create a list that includes in that list a text A, B, and C. In column 2, I'm going to create 3 objects. That is because I already have a list of 3 objects. So here I have this list, a character list of 3 objects. Remember, that is the number 1, the word 2, and the number 3. Then in the third column, I'm going to create a list that is object A, object A, object A. Well, object A is the number 1. So I'm going to create a column of 1s here. So when I run this, it creates a new object. Notice this is under the data classification. So it says I have this df object. If I click on this arrow, it shows me the columns that are in this data frame. So in the data frame, I have 3 rows, 3 observations, and the data frame contains 3 columns. The first one is a character column, the second is a character column, the third is a numeric column. There are many ways that I can look at data, so let me show you some of them. One is we could, in the same way we output what was in an object, we can do the same thing with the data frame, and that will come out in the console. So here it shows that I have 3 rows, 3 columns, and it shows me what's in this data frame. I have a column 1 that's A, B, and C, column 2 that is 1, the word 2 and 3, and column 3 that are all 1s. Another way to look at that is to type in capital V view, and this will open up the data frame for us to look at. And notice here it kind of looks like an Excel spreadsheet, and we can do a few things sort of related to that. So I could click on the arrow here and it'll sort it. That's about all we can do. We can do, some other minor things, but we're going to do them in an easier way. So sort of like an Excel spreadsheet. Another way to do it that we can use in RStudio is I can just go click on this data frame, and it will do the same thing as the view command. It'll pull up this data frame for us to look at. Well, let's say that I want to pull out something out of that data frame. We can use these same square brackets to do the same sort of thing. So I'm going to take from the data frame, these are the X and Y coordinates. So if I pull out, the row comes first, so if I pull out row 1 and don't put anything in the column portion of the square brackets, then it will use all columns. So I have here, pull out all columns from row 1, or I can pull out all rows from column 3. Notice they're showing up in the console here. So now I've got a list from row 1 or a list from column 1, or I can pull out an individual cell. So I could pull out row 2, column 1, and that's the letter B. Again, we can use these square brackets to subset and pull out items from the data frame or from an object that we have. Another aspect of R is using packages, and packages are code that have been written by contributors to R, and it allows us to do some things that would be hard otherwise, that would take a lot of lines of code. So using a package requires 2 steps. The first is to install the package on your computer, on your system. So this is the install.packages. Notice it's in quotation marks. This will put it on your system. Once it's on your system, you can stop using this install packages part for that package. Because it's already on my system, I never need to use this again. But every time I use R in a new environment, I need to read into the library that package. So here, if I don't read this in, it will tell me I don't have that package available. It'll give me a warning in the console. So here I can use that library, use that package in my library. So now this readr package is available. That readr package is a package that allows me to import data using some different commands than the base R commands. Here we will import some data. A couple of things to notice. So readr has a few functions. The function we will use here is read_CSV. We could use other sorts of read Excel or other items that we may use at some point. A lot of times we'll use CSV files, so that's why I'm starting with that. Then I read from a file, so I need the file path. In R, the file path is a /. So if you go copy this and you're in a Windows machine, it'll have backslashes. You'll need to change these to /. But once we have it as a /, notice I go down to the end here. The file that I'm reading in is a CSV file. The file is for a mountain biking company that sells mountain bikes and other gear. So we will use this data to start understanding R and some of the ways that we use data in financial analysis. So I pull in this data, I read it in, once I read it in, I'm saving it as an object GBI DTA, so I refer to that as my GBI data frame. So I run this. It gives me some information about how it read it in, so if there were problems, we might look at that, but it just tells me what's available. And notice here I have an object that opened up, GBI DTA. It has 36,000 observations, so 36,000 rows. And it has these columns: customer, product, distribution, year, month, day, sales quantity, unit of measure, revenue, currency. So we can look at this. If we let it output into the console, 36,000 observations is a lot to put in a console, so it won't give you everything. So easier is to do the view command or click on GBI data and look at it here. So let's look at the data and what we have. This is a wholesale company that we're dealing with, so they're selling to retailers. So we have a retail company, Airport Bikes, that is buying from the wholesale company. And then if we keep going down a ways, we'll see we have other bikes that are also buying from the same company. We have different products that they're using. We have when the sales were made, so with the year, month, and day of the sales, how many units of that product were sold. So here, 3 units were sold. This is the total revenue that came from that. This is the discount that they gave to that customer. This is the net of the revenue minus the discounts. And we have different sales organizations within the wholesale company. So we have US East, US West, and Germany South, and Germany, I think, North. So different organizations that are doing this, and a bunch of sales information. So then we could look at the data to understand it a little bit, and we're going to start with this most of the time. So a summary gives us information about each of the columns in the data set. So if I run this, it's going to output it in the console. And let's look at some of what's available here. So it tells me customer is a character, can't tell you much other than that. Product is a character, distribution is a character, so we can't learn much about those. Year, the earliest year we have in the data is 2008. The latest year we have is 2011. Month is a character. Well, it's a number, but it's put in as a character, so if we want to use it as a number, we might need to change that. Same thing with day. Unit of measure is a character. Revenue tells us something. So we have revenue. So this is a product being sold and the number of units that were sold. So this is the total revenue on a sales purchase. So we have some purchases that are, some items that are purchased for only $14. We have some others where they purchased multiple bikes and one item that's really large, so $189,000 in a purchase, but most of them are maybe in the hundreds or thousands. We have discounts too, so discounts that are small, and then one really large discount, I assume, goes with this. And then the net sales is what's after taking the discount out. Then the characters, again, we don't learn a lot of information from those. So numeric, what that does is gives us some statistics to look at: the minimum, first quartile, median, mean, third quartile, max. This allows us to look in and see if we have errors, if we have things we don't understand in the data. So once we understand the data a little bit, we're going to work with it, and we're going to introduce a package here that we are going to use frequently throughout the course. This is the dplyr, dplyr, or however you want to refer to it. Most of the time I go with dplyr, but however you want to use it. So I already have this installed, so I don't need to install it, but you will need to, and then I read it into my library so I can use it. We need to talk about the dplyr language. Here I have a lot of the functions that are available within the dplyr language, and I will go through these. It gives us an output that I don't really care much about, but it gives an example of how we might use this data. And each of these functions, so notice here I have arrange, filter, mutate, group by, summarize, ungroup, and distinct. We can use these in any order that we want to use them in, and we don't have to use all of them. Sometimes we'll use just mutate or just summarize or just group by. But here I want to lay them all out and give you an example where we might use all of them so that you can see how they work. An important part of the dplyr framework is this here. This percent greater than percent is called the pipe function. The pipe function, what it does is combine commands together. So here I have an object that I'm creating, TMP, I refer to that as temp. So I'm creating an object temp that is going to be a data frame, and I'm assigning to it everything that happens over here. So I take GBI data, I'm going to assign that to a new data frame temp, and the pipe function says continue on, do something with this GBI data. So in other words, every time I see a pipe function that says take what is on the left of the pipe function and do whatever you see is on the right of the pipe function. So if I just ran, let's say, this part of the code, I run GBI data, continue on, do something that's on the right of that, arrange that. Arrange is the sort function in dplyr. So sort GBI data by these columns. So sales organization, year, month, day, customer, product. Then if I keep running with this next pipe function, it's going to wait and think that I have something else to do because I'm telling it to continue on. But I haven't provided it anything to continue on. So if I run this, notice I have a plus sign down here in the console. It's waiting for another command because I ended with this pipe function. Well, then I have to tell it something else that's going to make it have an error. So I usually just put in a bunch of closing parentheses. It says, oh, error, I didn't know what to do with that. On the other hand, if I stop before I get to this pipe function, now what it has done is say create a new object temp from the GBI DTA, do something to that GBI data, and that is sort that data, and then stop. So if I go over here and look at temp, that's the same, has the same number of rows, all it's done is sorted the data. So if I open it, notice it is sorted by sales organization first. So if I go over here, I see Germany North as the first organization, Germany South is the next, US as the last two. So this is how we would sort it, arrange by however many columns we want to sort by. And if we want to continue on and do something else, we'll add a pipe function. And now let's do filter. So filter is a way to only keep rows that meet the criteria in the parentheses. So here I'm making criteria that the column year has to be equal to 2011. We use the double equal signs to mean is equal to. Otherwise, it'll think you are trying to create a new column year, so then it'll get confused. So to do a logical evaluation that involves an equal signs, we do double equal signs. So here it's going to say keep only rows, so filter, keep only rows where year is equal to 2011. So if I run this, it's going to take GBI data, sort it, then only keep rows where year equals 2011. If I want to do more, I can do an or sign, which would be a vertical line, and I could do year equals 2010. So then that would keep year equals to 2011 or year equals to 2010. Or I could do and, so I can do an and sign and say where year equals to 2011, and I could add some other criteria. Here I'm only using one criteria. So the filter here says only keep rows that meet this criteria. So once I run this one, now notice I've gone from 37,000 observations down to 9,000 observations. These 9,000 observations are only those where the year is equal to 2011. And notice something that I'm doing here that maybe you're already at that best practice stage, but always when I run something, I go and check what the data looks like to make sure that what I've done is what I expected to have happen to the data. So let's continue on. So we're going to add another pipe function so we can do something else to the data. And that brings us to mutate. Mutate is to do something to the columns that are in the data set. And usually that means creating a new column. So here I'm going to create a new column that I'm going to call gross price per unit. That is the total revenue divided by the sales quantity. So revenue is the total amount of that sale. Sales quantity was the number of units that were sold. So this gives me the gross price per unit. Then I'm going to also do the net sales, which is the revenue minus the discount divided by the sales quantity. So this is the net price per unit. So if I run just this part, I can open up temp. At the end, you will see I have created two new columns, gross price per unit and net price per unit. And these are, notice here, I've got one unit that was sold, so that one unit will give me the same as I have in the net sales and the gross revenue. But in one where I have more than one unit, so here I have 2 units, I've got this revenue of 5,000. I divide by 2, this gives me 2,500 here, and there was no discount. Here the discount was 0. Okay, so new column. Then let's say I want to do something else, and here I'm going to use the group by function. The group by, all it does is tell dplyr to keep objects that are according to that group together. So anything that happens after a group by statement will be done by those groups individually. So it treats them as separate data sets. So here I'm going to say treat the sales organization and months as separate data sets. You won't see anything in this, so when I run this, notice you don't see anything about group by. I open the data set, it doesn't tell you anything about how it's been grouped. So the group by part is a hidden aspect of dplyr, and that it'll tell R that the data is grouped. So then when you do something else to it, the grouping happens. Because of that, usually at the end of some set of code, I ungroup it to make sure that I don't have this hidden grouping function going on. Okay, so I group by this, then do something else, and this is where group by matters. So summarize is like mutate, except it only keeps what is in the group by part and in the summarize part, and it does summary functions. So summary functions meaning you aggregate up data across rows. So here I'm going to use the mean function, so it's going to create a new column, mngppu, which for me is mean of gross price per unit, is the mean of this gross price per unit column that I created up here. Same thing with the net price per unit. I'm creating a new column here. So if I run this, notice I'm not including the pipe function again. I go up here, run up to this point. If I can get it to do that. Now the temp data frame has only 48 observations. That's because I have 4 sales organizations and 12 months in 2011. So if I open that, notice I've got month 1, 2, 3, 4 for each sales organization. Here's the average price per unit for gross price per unit and the average net price per unit for each of these organizations for each month. So then I can ungroup it. That doesn't do anything, it's hidden, but what it means is anything I do after this will not be run separately by group. Then finally, the last one is distinct. This is removing duplicate rows. And by duplicates, it uses any columns that we have in the distinct function. So here I'm going to say, keep only the first time of a sales organization. So each sales organization only keep 1 row for that. If there's a duplicate sales organization, it removes it from the data. Well, I actually have here the sales organization by month. So what it will do is just keep the first row it has for each sales organization. So when I run this, and look at the temp data. Notice I only have 4 observations now. That is because it's only kept the first month for each of those sales organizations, and that's because also I sorted it by month before. And so then it gives me for January, remember it's in 2011, for this sort sales organization, the average price per unit, gross price per unit was this, the average net price per unit was this. Notice there are some differences across the organizations. So US West is selling on average the higher priced items. Germany North is on average selling the lowest priced items, and they're each giving some discount on their sales. All right, so again, let's summarize, not summarize in the function, but summarize in dplyr what's happening. So we create an object. We use the assignment operator to do it. We are starting with the GBI data, doing something to it with this pipe function. We're sorting it. So arrange is sort, filter is keep only certain rows, mutate is create a new column, group by is to do anything that comes after that separately for each group, summarize is to aggregate with some summary functions rows by the grouping function. Ungroup is to remove the grouping so you don't inadvertently do something after that by group that you didn't want to do by group. And distinct only keeps non-duplicate rows based on the column that is input into that. Here, this dot keep all equals true keeps all columns when it does this distinct function. If you don't do that, it'll only keep the columns that you put in explicitly. All right, so as you get started, hopefully this gives you sort of a good start. I will have you work through some practice with these commands. Once we have these commands under our fingers, then we're going to start using them to actually do some analysis.